I think we can agree that the line of equality is possible. 20% of the households with 20% of the income, 40% of households with 40% of the income. Is it possible to be on the axes?
Yes.
Okay? Describe to me what that would look like, because I'm not sure that it is.
Okay. So if we're looking at extremes, so say there's more than just the 5 people we listed, more than John and Ben.
There's 311 million of them. Is that extreme?
Yes.
Or there's 1.4 billion of them. That's extreme.
Right.
Okay.
So we are looking at inequality and we're looking at extremes on where our line is, but you could have people as outliers who are maybe closer to the graph. So instead of having somebody who is like 100% of the household, you could have like 1% of the household. Oh wait, hang on. I'm looking at your graph wrong.
No, you're just arguing my point, as it turns out. Jim?
Oh,
I'll help her.
Thank you.
thank you.
For A to ever be 0.5, there would only be one person out of whatever group making any income.
In fact, frankly, there couldn't even be one person, because that one person
Well, that's
would
true.
be some tiny, tiny, tiny little variance off of the edge. Okay? There couldn't even be one person. It's literally impossible for it to technically live on the axis. We can't expressly have a corner solution, but we can come so close as to the difference between that number and 0.5 is insignificant. And what that would mean is only one person out of this 1.4 billion owns it, or has all the income, and the other 1,390,999, has nothing. Joel? Oh, I thought that was a hand. Okay. So those are the limits. The Gini coefficient, which is what we're about to create, the Gini coefficient can be 1, excuse me, can be 1, cannot be 0. Has to be greater than 0. So you're about to see the remainder of this. We're about to come up with the Gini coefficient, which is going to be A divided by A plus B is equal to the Gini. Yes.
This one's a hand.
Okay. Give me a minute. I'm trying to get the signals there. It's taking me 7 weeks.
A plus B, always a constant, so the denominator in there, why bother taking that ratio at all? Just it makes it look nicer, or, because just A on its own is the only thing that expresses.
Because A is an absolute number, and I want something relative. I want a percentage. I want a ratio. Because if A is 5 versus A is 150 million, I don't know anything about the equality or inequality. Yeah. Ratios are cool, as it turns out.
How do you solve for A though?
Well, I'm about to tell you,
Oh.
as it turns out. Okay? Because A looks like I got to identify the area between a slope and another slope, and I know that if I have equations for those slopes, and if I know calculus, I can take and I can use the integrator. But we're not going to do that because I'm not mean-spirited. Okay? Do I also know the area of B?
Minus A.
Yeah. In fact, I can say that A, since I need to find A is equal to 0.5 minus B, right? Subtract B from both sides of the equation. And it's a lot easier for me to find B, because I got a nice horizontal line here, I got a nice vertical line here, I got a little bit of safety in this view. Do I know what the base is for this triangle?
1%.
0.2, right? Do I know what that leg is? It's 0.6, it's 0.0684, right? Okay. Do I know what that leg is?
0.2 again.
It's my cumulative leg, right? And 6.4? Do I know what that leg is, this little sub leg? It's 13.89, right? Yes.
So, can you just calculate a trapezoid rather than splitting them up? Is there a way to do that by using that,
You know,
A equals 1/2?
I
B
am not
1
good
plus
enough
B
with
2?
geometry to be able to answer that question. And I've never seen a textbook do it that way.
Do we know the height of that?
Well, we know this height, we know that height, and we know that. We don't immediately know that distance, and that might be our issue. I don't know. I know this is the poor man's, simple man's way of doing it. Meet the simple man. Okay? And meet each of the textbooks I've ever seen this discussed in, were written by less simple people, including your buddies, Aaron Hart Smith. So we know that this leg is 13.89. We've got the same thing going on here. I'm going to move B for a minute. We know that this leg is 37.93, and that this part of the leg is 17.84. We know then that this is 0.6207, and this is 24.14, or 0.2414. And we know that this is 1 point. Okay. And I think now we have enough information to be able to calculate the area of this triangle. 0.2 times 0.0684 divided by 2. 0.2 times now this rectangle, so 0.2 times 0.0684 is the value of the rectangle, and the value of the triangle is going to be added to it, of 0.2 times 0.1389 divided by 2, and so on, and so on, and so on. It's hard for me to think about this area right here, because I got a funky kind of shape, and I'm just not that good of a geometrist, okay? But I can get my little head around a triangle and a rectangle. I've known those equations for a long old time. Charlie's laughing at me. He said, you know, you're not that smart, Rick, but you can probably do this thing, right?
I'm just saying, I'm thinking the same exact way.
Yeah, see, it's the way I would think about it, and fortunately, it's the way that most of the textbooks describe it as well. So I can identify the value of B. And I can take 0.5 minus B, and it equals A. And now I can take A divided by A plus B to get my Gini coefficient. And we can take a few minutes to do that. Well, in fact, what I'd probably rather do at the moment is to go ahead and relate you back to the videos, and maybe if you'd like me to do it, since I've also recreated this on the back script, the back board, if you'd like me to do it after we have some other exam review, I'm happy to come up with a number for you. Okay? I just think that we have a time budget, we may want to do some more exam reviewing. Let's assume for a minute, I don't think this is accurate, but let's assume it is. If this Gini coefficient was equal to 0.32, let's say, what would be the Gini coefficient of a less equal society? Or it could be the Gini coefficient of a less equal society. Would it be more than 0.32 or less than 0.32?
Less, 0.2
of a less equal society?
Less than 0.32.
Well,
The area
I
would be
think-
just less.
I think it would be greater. Because if it's less equal, then my curve is under the Lorentz curve, my area of A is bigger. If my numerator is bigger and my denominator is constant, I think my outcome is bigger. So, and if I had no A, then what's my Gini coefficient? What is 0 divided by 0.5? Well, 1 divided,
Oh, yeah.
0 divided by 0.5 is unknown, right? It may as well be 0. So perfect equality would have a Gini coefficient of 0. Right? If A was the entirety of this, so we had horrific inequality, we could almost be 1, but not quite 1. So if the Gini coefficient is larger, if one is larger than another, it suggests that an economy is less equal than it was, or than what we're comparing it to. If the Gini coefficient of Madagascar is 0.4 and the US is 0.3, Madagascar is less equal than the US. So we're farther away from equality. All right, and again, when we're done with some of the reviewing, we can go to the backboard where I already have all these same numbers already articulated, and we can calculate the coefficients and such. Yeah, Stephen, that's how I knew the numbers so quickly without you guys having to calculate them for me. I've done it in advance. I just didn't take it all the way. Okay, any questions about where we've come so far with respect to inequality?
Would you look at the Lorenz curve for an analysis and look at the shape in addition to the Gini coefficient?
Good question.
Couldn't that, if there was like a horizontal line to 60 or something?
Let's say that I came here
Yeah.
and had a very shallow slope,
Yeah.
and then boom.
Yeah.
That would represent a median and mean issue, right? Okay, so we can do that. Is it possible for the Lorenz curve to be above the line of equality? Why not, Holly? You're right. Because it would mean that the bottom 20% of the households has more than 20% of the income, and then it's no longer the bottom 20% of the households. Can't be. Just can't possibly. That's why. So the most common mistake I see people make when they're representing this curve is sometimes they'll try to put it above the line of equality. Not so much with that. If you're calculating it above the line of equality, start over. That's a pretty good rule of thumb. Okay, I haven't given you guys a break. Let's take a brief break. Maybe even on that break I'll calculate the Gini for you. And then we'll come back, and I want you to start to ask me some questions about, some clarifying questions about compensating wage differentials, mobility and migration, human capital investment, discrimination, pay and productivity, monopsony. I don't think we need to talk more about unions or inequality. I think we've pretty much hit them. Fair enough? Let's take about 10 minutes, and let's come back at this.
Do we need to send you an email for the final?
Yep.
Okay.
I just need to make sure I know who to expect.
That's Mondays.
Yeah, it's going to be Monday night.
We